How to avoid jetting in injection molding. One of the potential drawbacks of the injection molding process is a defect known as jetting, in which the molten material does not properly fill the mold and instead forms thin, string-like protrusions on the surface of the finished product. In this article, we will discuss some strategies for avoiding jetting in injection molding. What is jetting in injection molding? Jetting, radiation, or watermarks is one of some common injection molding problems. What causes jetting in plastic injection molding? The main reason for this is that the molten polymer passes through the nozzle, runner or gate, and other flow-restricted areas at high injection speed and then enters the open area, without achieving a close fit with the mold wall thickness. After the plastic flows into the injection mold, influence of jetting on injection molded parts. Jetting will cause many quality problems, such as the strength of plastic parts, surface injection molding defects, and internal defects of plastic parts, etc. Therefore, it is necessary to avoid the generation of jetting as much as possible. How to avoid jetting into injection molding? A. Change the mold design. Usually, the root of the problem of jetting comes from improper gate design. Therefore, the problem of jetting can be solved by changing the gate design to guide the contact between the melt and the wall of the mold. Using overlapping gates can improve such problems, as shown in Figure 1. Overlapping gates reduce the flow velocity of the molten plastic, thereby reducing jetting effects. The use of air gate or fan gate, as shown in Figure 2, can allow the melt to move smoothly from the gate to the mold cavity, so as to reduce the shear stress on the melt when it passes through the gate. In addition, increasing the gate and runner size and shortening the gate length are also directions to consider. It is important to properly design the mold to prevent jetting. The design of the mold plays a critical role in the overall quality of the finished product, and a poorly designed injection mold can result in defects such as jetting. To avoid jetting, the mold should be designed with properly sized and spaced gates and runners, as well as adequate venting to allow air to escape from the mold. B. Adjust the forming injection process conditions. Adjust the filling speed curve so that the front end of the melt can pass through the gate at a lower speed. Wait until the melt passes through the gate and then increase the injection speed to eliminate the jetting phenomenon, as shown in Figure 3. C. Another factor that can contribute to jetting is the temperature of the molten material. If the temperature is too low, the material may not have enough viscosity to properly fill the mold, resulting in jetting. On the other hand, if the temperature is too high, the material may become too fluid, which can also lead to jetting. To avoid these problems, it is important to carefully control the temperature of the molten material, using temperature sensors and other temperature control equipment to maintain a consistent and appropriate temperature. D. The flow rate of the molten material also plays a role in the formation of jetting. If the flow rate is too high, the material may not have enough time to properly fill the mold, leading to jetting. On the other hand, if the flow rate is too low, the material may not have enough momentum to properly fill the mold, also resulting in jetting. In order to avoid these problems, it is important to carefully control the flow rate of the molten material, using flow meters and other flow control equipment to maintain a consistent and appropriate flow rate. E. Another potential cause of jetting is the presence of air bubbles in the molten material. Air bubbles can become trapped in the material as it is injected into the mold, and if these air bubbles are not properly vented, they can cause jetting. To avoid this problem, it is important to use degassing equipment to remove air bubbles from the molten material before it is injected into the mold. Additionally, proper mold design and venting can also help to prevent air bubbles from becoming trapped in the material. F. It is important to properly maintain and clean the mold to prevent jetting over time. The injection mold can become contaminated with debris, which can interfere with the flow lines of the molten material and cause jetting. To avoid this problem, it is important to regularly clean and maintain the mold, using appropriate cleaning agents and tools to remove any debris and ensure that the mold is in good working condition. Conclusion. In conclusion, jetting is a potential defect in injection molding that can be caused by several factors, including poor mold design, improper mold temperature and flow rate control, air bubbles in the molten material, and contaminated molds. By properly designing the injection mold, carefully controlling the temperature and flow rate of the molten material, using degassing equipment to remove air bubbles, and regularly cleaning and maintaining the mold, manufacturers can greatly reduce the likelihood of jetting and producing high-quality products. If you have any other question about injection mold and injection molding, welcome to consult Zatar.